Hey, Algebra 1, we are still in Chapter 1, but we're getting closer to the end. We're going to talk about, in this section, relations. We have two sets of notes that I need you to keep aware of, or two sets of vocabulary, that I need you to keep aware of. This first set, I'm not going to require you to write definitions for, and then we have maybe about 6 or 7 more. And those you will have to write definitions for, but I'll be really expedient in showing you how to do it. So this first set, what I want you to do is merely draw XY axis, and we'll kind of talk about some of these terms so that you know how they relate. So the first thing is this XY axes, these pair of axes are actually referred to by three names, sometimes more: Cartesian plane, which I just wrote in, coordinate plane, and coordinate system. And basically it's a system of organizing information such that we talk about two coordinates to give its location. The name Cartesian comes from the philosopher and mathematician Rene Descartes, who kind of invented this. All right, so the XY axis, the x-axis is here, it's the horizontal one, and the y-axis is the vertical one. The origin is the center, so you can literally draw arrows to these. And then ordered pairs, well, if I were to refer to this point right here, that location, I would say that location is 2, 1. Notice X always comes first and Y always comes next. X1 is the ordered pair that is used to refer to that particular location. And finally, X and Y coordinates are listed as you see here. The first term of an ordered pair is the X coordinate, and the second term is the Y coordinate. So here's all your vocabulary, the rest of your vocabulary, and so we can talk about each of these. When we have a relation, that's a set of ordered pairs. So for instance, the following refers to a set of ordered pairs. I use my little curly brackets, and here's a set of ordered pairs: 2, 5, 7, 2, and 1, 9, and I can define that as a relation. Mapping is a way of demonstrating a relation by taking the two groups of values, like the X terms, which we're going to talk about as the domain, so that would be the domain here, and then the Y terms, which would be the group of them is referred to as the range, and mapping them together. So if you see that in this relation 2 and 5 are together, I draw a line from 2 to 5. If you see in this relationship that 7 and 2 are together, are mapped to one another, they're paired together, I'm going to draw a line to 7, 2. And clearly I'm going to draw a line to 1, 9. So it's just a different way of illustrating a relation. We already referred to the domain as the set of the first numbers in an ordered pair, so clearly this group right here refers to the domain. The range is the set of second numbers in an ordered pair, and so those are my range values. Finally, independent variable and dependent variable are two words that, or two phrases that come up often, that oftentimes really just says these are the X terms and these are the Y terms. However, I'd like us to look at the definition really closely so that we could make sure and have a pretty good handle on what's going on. So an independent variable, it's the variable that determines the output. So it's the output in this case is like the answer to the question. So if I had, for example, in equation 2x plus 3 is equal to y, y is dependent on the values of x. So X is the independent variable and Y is the dependent variable because the dependent variable is dependent on the input. Yes, this can sometimes change. Yes, depends on how you organize your equation, but typically this is how we represent or think about independent and dependent variables. You all have seen different representation of relations. I just wanted to let you know or show you in a real graphic way that ordered pairs, tables, graph, and mapping are 4 different distinct ways that you're going to be asked to show a relation. So I'm going to do that right now. So let's just say that these are the ordered pairs that make up a relation. We can write these ordered pairs in a number of different ways. By the way, there's no limit on the number of ordered pairs that can make up a relation. Written out as a table, this is what our relation looks like. As a graph, we need to make sure we have a XY axis, Cartesian plane, coordinate system, and we draw it, and then we are going to just plot the points. So I go out for up to 3, and there's my first point for 3, -2 to 1. My next point, +1 up to +5, 1, 2, 3, 4, 5. There we go. And then -1 to 0, so that stays right there on the x-axis. So I can represent my relation in that way, and then I can do it in a mapping. And you saw us do that last time. It looks like this. So you simply make sure you've got all the elements of the domain in one circle, all the elements of the range in another circle, and then you draw lines to it to show how they relate to one another. So -2 goes to 1, -1 goes to 0, +1 goes to 5, and 4 goes to 3. And I guess I could put arrows there too to indicate where how they map together. I think you guys are pretty savvy. You can probably do this example on your own. It just basically asks you to express a particular relation as a table, a graph, and a mapping, then determine the domain and range. And I know you guys can do it, so you can pause me. I'm about to put the answer up. Hopefully you all came up with the same 3 images that I have here, and the final thing that we were supposed to do is to determine which one is the domain and which one's the range. And we have the domain over here, and the range is this one. There we go. This next example gives us practice on determining which one is the independent and which one is the dependent variable. So we get to identify those. Let's look at this first example, part A. The more money that I have, the more I can spend on gifts. So the 2 variables are the money that I have and then the money that I spend on gifts. So I'm going to just use M for one and then G for the other one. So M is the money that I have, G is the money that I spend on gifts. Which one depends on the other? You guess. What do you think? Which one depends on the other? Exactly. The more money you have. So the more money you have is the independent variable, and it's independent. And then the gifts that the money that you spend your gifts on is dependent, because that's the one that depends on the other. Let's try the next guy. The average price of going to the movies has increased over time. Determining the 2 variables is a little challenging here, but let's think about it. We're talking about price of going to the movies, so let P be the price going to the movies. And the other thing is time. So we'll do P and T. So now we have to figure out which one depends on which. Does the price depend on the time, or does the time depend on the price? And when I say it like that, I think you realize that clearly the price depends on how much time has elapsed. So the independent variable is time here, and the dependent variable would be the price. Okay, good people, we have reached the end, and we are going to give our assignment, basically pages 41 through 44. And I'd like you to do the following problems. Please make sure and write them down, and I'll see you in class tomorrow.